Oke, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Welcome to the parallel session at the International Conference on Advancement in Data Science, E-Learning, and Information System, or ICADEIS 2025. My name is Saskia Putri Ananda, and, um, and I'm honored to serve as the moderator for this session. Today, we have a series of remarkable presentations that will explore about security and e-learning. Okay, before we begin, allow me to outline the format for this session. Each presenter will have 10 minutes to deliver your presentation. Each presenter has a maximum of 10 minutes to present. At the 8th minute, there will be a reminder that there are 2 minutes left. At the 10th minute, I will set the time's up. Okay, and then followed by a 5 minutes of question and answer segment. Okay, any question?
Okay, I think it's clear. Thank you.
So only one question, right? So we worked very hard to fit the presentation in 10 minutes in our pre-recorded videos. Would that be possible if it can be played, or should we just talk for 10 minutes? Because it was very difficult for us to fit in the entire presentation in 10 minutes. Is that possible to play the pre-recorded video to the moderator?
Okay, it's okay, Mr. Raza.
Prashant. Yeah, my name is Prashant. Yeah,
Okay.
sure. So I'll be there to answer any any questions that the team has over here. I'll be here. Yeah, I'll be here to answer them.
Thank you. Okay. Now, without further ado, let us welcome our first presenter, Mr. Reza Aulia Desri. He will present a paper titled Mobile Banking Security, Relationship Between Trust, Risk Perception, and Security based on UTAUT. Okay? Please join me in giving a warm welcome to Mr. Reza Aulia Desri.
Okay, thank you for the chance of this presentation at this international conference. Good morning, everyone. My name is Reza Aulia Desri, and I'm from Telkom University, Bandung, Indonesia. And today I will present my research title, which Mobile Banking Security, Relationship Between Trust, Risk Perception, and Security based on UTAUT. As we can see, the first one will be introduction. We will speak about mobile banking growth in Indonesia, security concerns and user trust, and modified UTAUT model application. Let's start. Next slide. Okay, as we can see on the graph on this side, mobile banking transactions in Indonesia have been grown rapidly from 1.58 quadrillion rupiah in 2018 to 4.26 quadrillion rupiah by 2023. This growth reflects the increasing adoption of mobile banking technology driven by its convenience and accessibility. However, this growth also comes with challenges. Major data breaches in 2023 compromised 1.5 terabyte of customer information, raising concerns about data security. Research highlights that trust is critical. Users are less likely to adopt mobile banking if they perceive high security risk. And to address these challenges, this research applied a modified UTAUT model, which incorporates 3 additional variables, like security, perseverance, and trust. This adoption allows us to better understand user behavior in the Indonesian context. Yes, going to the next slide, please. Okay, next is research objective. This is the objective, the primary objective from this research. Next slide. Okay, first we analyze how security concerns and the implementation influence user behavioral intention and the adoption pattern in mobile banking. And second, we will, this research investigate the relationship between trust, perceived risk, and security factors to understand the effects on mobile banking usage patterns. And the last is validate modified UTAUT model in the Indonesian context. Applied with this model framework, incorporating security factors to analyze mobile banking adoption in Indonesia, which achieving 76.5% behavioral intention of variance explanation. Going to the next slide, please. Okay, this is literature review, which the study for this research. Next slide. We will speak of the first one is mobile banking, adoption, and security factors. The prior research, I will explain about some of them. Like prior research emphasized that perceived risk negatively impacts behavioral intention, as found by Fan at 2020, with a path coefficient is minus 0.534, which and studied by Merhi at 2019 also noted that trust is influenced by security features and institutional reliability. And second is we're going to unified theory of acceptance and use of technology. UTAUT model, this model is created by Venkatesh at 2003, which was explained over 70% of variance in technology adoption. And previous studies often exclude security as key determinant, limiting their relevance and context where cybersecurity is a major concern. Going to the next slide, please. Okay. Differences from previous study. What is the difference between this study and previous study? In region like Saudi Arabia, studied by Abdullah at 2019 and Morocco by Lafraxo at 2018. This study evaluates the interaction between trust, security, and perceived risk, specifically in Indonesia. Additionally, we conducted a comprehensive segmentation analysis that goes beyond what previous studies offered. And the last is contribution of this study. The study contributes by adding security, trust, and perceived risk to the UTAUT model, increasing the explanatory power to 76.5% of behavioral intention variance, and addressing Indonesia's unique cybersecurity challenges. Going to the next slide, please. Okay, methodology. This is a methodology for this research. We're going to talk about segmentation framework, data collection, model application, and structural equation modeling. Okay, thank you. And first, segmentation framework. This research segmented users based on age, occupation, usage duration, and type of bank, providing granular insights into their adoption behavior. And second is data collection. This research collected data from 389 respondents via an online questionnaire. Each respondent answered 36 items of question. Rated on a 5-point Likert scale, the sample size exceeded the minimum required of 384 respondents calculated using the Bonelli formula, using a 95% confidence level and 5% margin of error. Next slide, please. And the third is model application. As we can see, the model that used in this research is UTAUT model, normal UTAUT model with, normal UTAUT model with 3 additional variables like security above the behavioral of intention, security, risk perceived, and trust perceived. As shown and that diagram, have the 8 hypotheses exploring relationship among variables such as security, trust, and behavioral intention, like I said before. And the fourth is structural equation. Sorry, go back before. Before. Yeah, structural equation modeling. We analyze the model using SAM PLS, ensuring robust reliability and validity. Metrics such as AVE is more than 0.5 and Cronbach alpha, which I explain in the next slide in the result. Okay, going to the next slide. Okay, this is the result and discussion, model validation and reliability result, path analysis and segmentation analysis. We can next to the slide, please. Okay, thank you. In this section, it will be model validation and reliability results, which we can see at the table, at the both table, both top and bottom table. We can see the score of AVE that these all variable that used in this research is validity, with values ranging from the lowest is 0.597 and to highest is 0.839. And for Cronbach alpha, for the reliability of the variable, we can see all of the variable is reliable to this research. And this value is got to the lowest is 0.794 and the highest is 0.936, and that is so about composite reliability. 0.855 is the lowest and 0.954 is the highest. Going to the next slide, please.
Okay, there are 2 minutes left.
Okay. This is path analysis that used in this model. We can see the diagram, the graph, and the table which showed the value from each relationship, the variable. The Perseverance, we can see at the table, Perseverance has the strongest negative effect on behavioral intention, which minus 0.534, while facilitating conditions show the highest positive influence on user behavior, 0.544. We can go to the next slide, please. Okay, this is segmentation analysis result, which, as I said before, this research segmented by using age group, cross level, and bank institution analysis from the jobs like others. Okay, as we can see in the graph, that is the result, and we can see with the 30 until 39 age of group is the highest behavioral intention and the lowest risk perception. We can go to the next slide, please. Okay, let's just speak about conclusion. Yeah. Okay, to conclude, this study validates the modified Utaud model, explaining 76.5% of variance in behavioral intention, and security factors like perceived risk and perceived trust dominate adoption decision, confirming their critical role. And this research finding also perceive the key findings like perceived risk is with minus 0.534 with the strongest negative influence on behavioral intention, and facilitating condition with 0.544, which most significant driver of use behavior, and trust and security moderately boost adoption intent for this mobile banking adoption. And going next slide, please. Okay, this is segment analysis result. We going again age group 30 until 39, highest adoption, like I said before, with lowest risk perception. And entrepreneurs with the job segmentation, strongest trust is 4.26, while civil servants face higher perceived risk, 3.45, and traditional banks like BCA outperform digital banks in trust, but like in inefficient driven behavioral. Okay, next slide is the last slide. Okay, thank you for the chance of speaking. Maybe that's all for my presentation. Any question?
Okay, thank you for Mr. Reza Aulia Desri for that insightful presentation. Now we will open the floor for question. If you have a question, please use the raise hand feature in Zoom. Kindly state your name and affiliation before asking your question. Okay?
Okay, may I asking a question, Mrs. Saskia?
Yes?
Uh, okay, I just want a question. This is a good research. What is your future research after that? Thank you. Oh, sorry, I'm Putu Agus from Udayana University. Sorry.
Okay. Thank you for your question, Mr. Agus.
Yes.
Okay. Please, Mr. Reza, to answer the question for Mr. Agus.
Yeah, thank you for the question. Good question though. And to answer that, maybe for the future research, we can add the cultural segmentation, like regional or etc. As we know, Indonesia have a lot of cultural, right? Yeah, that's maybe have slightly effects on adoptional banking and security for like that regional or that culture is more reluctant for the security adoption mobile banking.
Okay, it's so clear. Thank you, Mr. Reza.
Thank you.
Okay, thank you, Mr. Agus, and thank you, Mr. Reza. Okay.
Oh, I had one question. So I see that a lot of numbers are there on the presentation. I see a lot of numbers on the presentation. So were these surveys done by you, or maybe you refer to some of the existing papers for this surveys?
All the values that got a result in this research.
Okay.
Okay, this research was got from the respondents, online questionnaire respondents, which ask about this mobile banking adoption, right? Security, which in implementation in security context. So with that result, is imported to smart PLS software, and that calculated with SAM PLS, and that got that all the result, which validity, reliability, etc.
What was the size of the sample of your
The
research?
sample of, I'm sorry.
What was the size of the sample? How many?
The target with Chrome batch alpha is 384, but the result of the respondents before, it exceeded with 389 respondents.
Okay. Oh, sorry. My name is Prashant. I work at Salesforce San Francisco. Yeah, thank you.
Yeah. Okay, thank you.
Okay. Now we must present to our next presenter. Okay. Please welcome Mr. Iputu Agus Eka Pratama, who will present a paper with the title is Technology Enhanced Learning for User Security Awareness using AI-based naive RAG design and prototype. Please welcome.
Okay, thank you, Ms. Saskia. Hello, everyone. My name is Putu Agus Eka Pratama. I'm from Udayana University. This research is a collaboration from Udayana University, S.Kom University, and also Mayar, Singapore. Okay, next. Yeah, okay, next, because of the time. Okay, we know that the rapid development of information technology, on the other hand, increase the number of cyber attack like the social engineering, also phishing, man-in-the-middle attack, and advanced persistent threat. It's triggered by the low understanding and awareness of cybersecurity among users, and also it's need effort to educate user and increase cybersecurity awareness need to be made. So several solutions are available, like the provision of free cybersecurity guide on the internet, discussion forum, workshop, and also paid consulting service. But all of them have not been able to reduce the number of cybersecurity targeting users. The artificial intelligence, as one the IT field that is growing rapidly now, are used in some area like today. So it's some important to adopt it to the solution. Generative AI or Gen AI is the form of the large language model or LLM that most widely used AI method in implementing AI-based solution. Okay, next. Yeah, because of the time, there are several studies that we have time to design and develop prototype AI-based learning system, learning technology. Okay, next. Okay, next. Yeah, related to the case study raised in the action of reviews research that raised the case study and the solution, this study proposed to design and develop a prototype of an AI-based application to help educate users about the cybersecurity awareness. This paper focused on the design and development of a prototype of a technology-based learning system using AI with the naive RAG method to increase user security awareness. The system will be utilized and optimize the resource of cybersecurity document and guide owned by the user as an internal knowledge base. Okay, next. Okay. On the literature review, we collected secondary data and reading various literature on the application of AI in the field of the education and teaching. We came from several papers in scientific journal and conference. For the tools and material, we use the hardware and software, and also we use the large language model like as a future development AI, especially in natural language processing. We apply deep learning technique to computer using transformation architecture to learn and understand complex and structured pattern as a language and large amount of data and semantic relationship between word and phrase. Okay, next. Yeah. Talking about the retrieval augmented generation is a method in LLM that uses dataset to generate text by combining information retrieval capability or retrieval and text generation. And also it consists of three steps: retrieval, augmented generation, which are related to retrieve information from user input, searching for contextual match, adding text, compile, answer, or system, respond to user based on generative AI. Talking about the naive RAG, it also consists of three steps, like a retrieval, augmented, and generation. Okay, next. Yeah, in the right is the diagram about the naive RAG. So a vector database is a database dedicated to storing digital data in the form of vector that represent mathematical formulation to facilitate machine learning model in AI to support search, recommendation, and text generation. Data match in the vector database identified based on the similar metric allow AI-based computer model to understand data contextual. The retrieval process function to obtain information and knowledge, the augmented function to help obtain a match between the user query or context and the availability of knowledge in the vector database, and the generation function is to compile, respond, or answer from the system to be displayed on the application interface to the answered question submitted by user. Okay, next. Okay. We name this framework and prototype user security awareness smart consultant that meet the following specification, like a web-based and online system, multi-platform, easily accessible to user, synchronous process with event-driven architecture, and so on. We also use the black box testing to test the functional of this prototype using the scenario testing. Okay, next. Yeah. This is the diagram for our prototype design of the user awareness smart consultant that focus on the stake of uploading document by user as internal knowledge-based data processing, convert document to vector, and data store to vector database. The user upload the document in PDF that function as an internal knowledge base. The document is referred to prototype to obtain knowledge to compile answer or system response to question from user through the augmented and generation state in NAVRG. Okay, the document also have been uploaded to the system, then undergo processing or data processing with the help of a broker. Furthermore, with the help of the broker and event-driven and synchronous document expression, chunk, document conversion into the vector, and data storage into a vector database. Okay, next. Yeah, this is our flowchart design. It's just small, yeah, from the start until the end. Okay, because of the time. Okay, next. Yeah, this is our scenario for black box testing. We have 1, 2, 3, 4 until the 7th step from login to system until the match of the system answer or response with the explanation in the reference document. And the result is next. Okay, all of the sequence step, the result is appropriate. This show that the overall the user's Kutemana Smart Consultant prototype was built by the specification and design. Okay, next. Yeah, this is some of the screenshot when we testing on the black box testing. Like a video 4, 5, 6, and 7. While during the text processing, question asked by the user and the system respond in Bahasa Indonesia and English. Also, the matching between the system answer and the knowledge in the reference document, like in video 7. Okay, next. And then we calculate the percentage of success from the black box testing using the formulation. Percentage of success is number of success test case divided into total test case, and also plus with 100%, and the percentage of success, because all is appropriate, is 100%. From this result, the percentage show that all functionality of the development of users Security Smart Consultant prototype has run well without any error and according with what's decided during the design process. Okay, next. Yeah. The user security awareness smart consultant prototype was successfully developed according to the specification and design based on the requirement and case study regarding the importance of increased
Sorry,
users.
there are 2 minutes left.
Okay, thank you, Saskia. Based on the requirement and case study regarding the importance of increased user security awareness through the provision of better security education and learning service using technology, especially AI, using the NIFRG. The result of black box testing also give the result that very good. Okay, next. Yeah, based on the black testing and test itu, the overall functionality of the cybersecurity learning prototype development based on the AI using IPRG has run well by the design and specification of the needs, and the system can make internal user document as the internal knowledge base and optimize them to provide response related to question asked by user. Okay, Saskia, next. Okay, for future research, will be continue by making re-ranking and other improvisation in the NIFRG to produce a better system response to improve research awareness and understanding related to cybersecurity learning. Okay, next. Yeah, okay. We would like our gratitude to Dayana University, Telkom University, and also Mayer International Corporation, Singapore. Okay, next. Okay, this is the reference. Okay, the last. Okay, next. Okay, next. Okay, thank you everyone for watching my presentation, and thank you.
Okay. Thank you, Mr. Iputu Agus Eka Pratama, for that insightful presentation. Now we will open the floor for question, but only one question. Okay, if you have a question, please use the raise hand feature in Zoom. Okay, any question? Okay. Mr. Putu, I think this is
Yeah.
an interest study, but I would like to ask. So,
Yeah.
Uh, do you think the result of this research meet your expectation?
Sorry for my bad English. Yeah, I think it's yeah uh yeah with my expectation is so yeah not so good, yeah, Saskia. And also we think we will continue this research with the another improvisation in the future, because maybe talking about the cybersecurity awareness in the user security awareness is need many specification that we need to improvisation in this RAG system and AI. Okay, thank you, Saskia.
Okay, thank you, Mr. Putu. Okay, thank you for Mr. Iputu Agus Eka Pratama. Now let us present to our next presenter. Please welcome Mr. Zain Maulana Azmi. But I'm sorry, please for the next presenter, you can share your own PowerPoint because there is a technical issue. Okay, so please welcome Mr. Zain Maulana Azmi.
Thank you. Can you hear me, Miss Saskia?
Yes.
Okay.
Okay, please you can share your own PowerPoint.
Okay. Wait a minute. I will share my presentation. Okay. That's good. Okay. Is it clear? Miss?
Yes.
Okay.
Okay.
Okay. Thank you, Miss Saskia, and other participants in this conference. Let me present our works and our paper. And the title is Zero Trust Network Access to Secure Website Application based on ISO 25023 is like quality software standardization. And the author is me, Zainulana Asmi, with my friends, Mas Iqbal Fadil, Devita Putri Baron, and our guidance, our rector, Mr. Ari Musarudin Siddiqui from Department of Informatics, Institut Teknologi 10 November Surabaya in Indonesia. Next. This is table of contents like our paper. Number one is abstract. Number two, introduction. Number three, methodology. Number four, results from the experiment. Number five is conclusion. The end of the paper is future works. Okay. First, we can present the abstract. Okay, the study evaluates ZTNA or Zero Trust Network Access as a modern security framework, focusing on its impact on website application performance like response times and security. And our paper using ISO 25023 to examine and compare the response times and the security between the application with ZTNA and the application without ZTNA. And the results demonstrate significant security enhancement with minimal performance trade-off. Okay, the introduction we can describe in 3 point in introduction and 4 in objective. Okay, cybersecurity is, as we know, a critical priority as to struggle against advanced threat. And ZTNA operates on the principle of never trust, and always verifies, unlike VPN that we only one enter in portal and okay, we can access every single data in our VPN. And the study focused on balancing security with system performance. So the objective is assess the impact of ZTNA on web application performance and security, evaluate response time using ISO 25023 metrics, compare application with and without ZTNA implementation, and there are two applications, but with same server requirement and same application. The difference is only the position with ZNA and without ZNA. Okay, and the last is analyze trade-off between security enhancements and performance efficiency. Next, methodology. Okay, there are five steps to in our paper. First is environment setup. We control environment with identical server configuration between the application with ZNA and without ZNA. Next, while the application is running in each server, we check the monitoring attack surface with our firewall monitoring tools. And after that, we examine application using Gmeter to measure response times in each application. And next, response times analysis. The output file from Gmeter we consolidate in Power BI tools or in Visual Tools to comparison the average seconds and the response time between the application with ZNA and without ZNA. So the last steps is impact analysis of ZNA implementation based on performance testing. And our key metric is number of surface attacks and response time comparison. Okay, next. And this is the results of section 4. Okay, this is the dashboard from our firewall monitoring tools. It shows that application without ZNA were vulnerable to bot and DDoS attacks. That's why application without ZNA is placed in public server, and the ZNA is only placed in private server. So the attack surface is reduced to zero because attack surface is only attack in public. So ZNA is significant to enhance security in private server and ensuring better security. And ZNA has its main feature like continuous authentication from ZNA, which enhance protection. Continuous authentication is like when we access login, the ZNA is check the activity, and after login, we check the main menu or master data. The ZNA continuous check the activity from user activity. Okay, next, the results performance comparison. Okay, this is the results from Gmeter, and we consolidate in this visual response times per feature. Without ZNA, it takes 9.9 seconds, and with ZNA takes 11.5 seconds. Okay, it is slightly better performance without ZNA, but ZNA provide also significant security in application. Okay, next. This is average response times. So without ZNA, take 2 seconds better from with ZNA. Okay, the conclusion is okay, ZNA significantly enhance security with acceptable performance trade-off like that. Only 2 seconds slightly better performance than with ZNA. Next, suitable for organization prioritizing secure and efficient digital operation. And the third is findings can guide future implementation across various industry because in our study case is from construction industry that using ZNA for many application in private that that used by our internal employees. Okay, next. And future works exploring ZNA in various improvement setup, integrating AI for threat detection, and adapting for various industry. Okay, apply ZNA in diverse application environment. I think ZNA can use in private or cloud or uh, other environment that can be installed for ZNA. And to integrate with AI ML for predictive threat detection and anomaly analysis. And third is
I'm sorry,
develop.
2 minutes left.
Okay, thanks. This is the end of our paper. Develop tailored ZNA solution for various industries. Okay, thank you for your attention. Okay.
Okay, thank you, Mr. Zain Maulana Azmi, for that
Yeah.
insightful presentation.
Yes.
We will now open the floor for question. If you have a question, please use the raise hand feature in Zoom. Okay. Any question? Okay. So, I think this is an interest study, but I would like to ask to Mr. Zain. Okay.
Okay.
So,
Yeah.
why you use ISO 25023 as the standard for measuring performance in this study? So why you choose
Yeah.
ISO 25023? Okay.
Okay. First is the ISO is about quality performance measurement like performance efficiency, like security improvement, or like usability testing. And a standard is using in many paper before in our research. So we use those paper. And the second, our guidance or our lecture is recommend to use this ISO to measuring and comparing the performance efficiency like response times, resource utilization, and others.
Okay, thank you, Mr. Zain.
Okay.
Okay. Thank you for Mr. Zain Maulana Azmi.
Mhm.
Now we present to our next presenter. Please welcome Mr. Ricky Miroj Ahmad, who will present a paper with the title is The Deletion Attack on Database Watermarking for Tracing Partial Data Breach. Okay, please welcome Mr. Ricky Miroj Ahmad. Please, you can share your own PowerPoint.
Okay. Um, wait, sorry. I couldn't find my file. Okay. So is it visible now?
Yes.
Okay. Thank you for the opportunity. Good morning, everyone. My name is Ricky Miroj Ahmad, and here I will be presenting our submission for this conference with the title of Deletion Attacks on Database Watermarking for Tracing Partial Data Breach, with me myself as the first author, and Mr. Baskoro Adipratomo as the second author, and Mrs. Diana Purwitasari as the third author, and we are from 10 November Institute of Technology. And here are the several content lists. We will start with introduction and we'll continue with related studies and contribution. And we'll follow with research methods. And last but not least is the experiment results. So there are are several goals. First one is to address the limitation of previous research. And second goals is to implement the database watermarking algorithm by Agrawals. And the last is to do the deletion attack and to analyze and assess the algorithm performance. So the contribution of this paper lies in implementing a database watermarking method based on Agrawal et al. Work and analyzing its robustness against deletion attacks. And unlike prior studies, we investigate the impact of the database size, specifically the number of rows on the accuracy of the watermarking method. And our findings highlight a significant correlation between database size and watermark accuracy, providing new insights for optimizing database watermarking techniques. Sorry, I missed the first slide, the introduction. So let me start again from this. So data breaches have become a significant challenge with sensitive information being exposed, causing reputational and financial damage. And for example, a 2021 breach in Indonesia leaked the personal data of over 200 million citizens. Database, and we can one of the techniques to provide solution for this challenge is to use database watermarking. So basically, it's just a steganography method or data hiding method where you embed some secret watermarks to a database. So database will be the medium for this steganography method, and this way we can prove the ownership of the database. So in case there is a breach or a leak data, we can trace the source of the leaks. And this paper will be implementing the database watermarking method proposed by Agrawal et al., which is the most used watermarking method, and assess its robustness against deletion attacks. So previous studies never done the analysis of database size on the deletion attacks. So that will be the main contribution for this paper. We are back to the contribution. So yeah, the contribution will be to investigate the impact of database size, specifically the number of rows and the accuracy of the watermarking method. These are several related studies. The first study will be the Agrawal et al. Study itself, who proposed the algorithm or the base of this algorithm, and the rest of the related papers are the papers who use the algorithm by Agrawal to improve their own watermarking method, and all of them have done the analysis on the robustness to deletion attack, but none of them consider the database size. So that's what we are aiming here. And the research methods, it's pretty simple. We use the data set used by the Agrawal's paper, and we, of course, implement the algorithm itself, and we perform the deletion attack. We analyze the performance, and we reduce the dataset size to see how the size impacting the robustness of the algorithm. And this is the Agrawal's algorithm. So basically, he just do a for loop in every rows of the database, and then for each row, he used some formula to decide whether the rows will be chosen to hold the watermark bit. So we embed the watermark bit by bit into the database rows. And how we do that is we replace the least significant bit of the selected value in the attribute of the selected rows with the watermark bit, with the XOR of the watermark bit and the mask. And how we extract the watermark is just the reverse of this embedding algorithm, so it's pretty straightforward. This is the experiment result. So the first result with all of the data in dataset, which is 581,012, and this result is the baseline of this experimental results, which is done by all of the previous studies. So they are all using this data, the 581,012 data, and of course they all achieve a very high performance, very high accuracy, very promising result with almost perfect accuracy during 10% to 99% data deletion on the dataset. But if you look at the table 2, where we reduce the data in the dataset by half of it, 145,253, and we can see slightly decreasing watermark accuracy. And this is what we are aiming in this paper. They didn't consider the dataset size on doing the performance analysis. And we continue with few more or less data
Okay, I'm sorry, there are 2 minutes left.
with 9,079 data. We can already see that the accuracy is no longer promising, with 90% data deletion achieve only 55% accuracy, and we go more with more or less data with only 2,270 data, and we can see that it's no longer achieving high performance. And this is the graphic chart of not reliable performance with experiment 3 and 4. So what's the finding here is that the algorithm is highly effective against deletion attacks in larger datasets, but struggles to maintain robustness as the dataset size decreases. This highlights the critical importance of the dataset size in ensuring the reliability of the watermarking and extraction process under deletion attacks. And additionally, these results suggest opportunities for future work to enhance the algorithm resilience, particularly in scenarios involving smaller datasets or more aggressive deletion attacks. Yeah, that's all for me. Is there any question?
Okay, thank you, Mr. Ricky Mi'raj Ahmad, for that insightful presentation. We will now open the floor for question. If you have question, please use the raise hand feature. Okay? Any question? Okay. So, Mr. Ricky, I would like to ask you, so why do you think this research is important?
Okay, thank you for the question. As I already mentioned, all of the previous studies using this algorithm by Agrawal work didn't consider the dataset reduction part in their analysis of the robustness. And this is what we are trying to address to uh, consider the dataset size in the impact of the performance. And as we can see, it really is impactful. Yeah,
Okay,
that's
thank you.
my answer.
Okay,
Thank you.
any other question? Okay. Now we will present to our next presenter. So, please welcome to Mr. Krashan Joshua.
Yeah, yeah.
Okay. Please share your video.
Yeah.
Okay. Thank you.
So, should I play the video or you're going to play the video?
You can share your video.
Okay, sure. Just a minute, please. Okay. Okay, just 1 second, please. I'm not able to maximize it. 1 second, please.
Okay.
I'll share my screen. You're able to see my screen?
Yes.
Okay, I'll play my video. Thank you.
Okay.
Hello, my name is Prashant, and our paper is a critical framework for fault tolerance and distributed deep learning. This paper was authored by me, and my co-author is Sethuraman, and I'll be presenting this session today. So before we move on to the actual content, the agenda for this session would be I'll be talking about why fault tolerance is critical in distributed deep learning and how it plays an important role in large-scale systems and stateful processes. And for this framework, for the specific framework we've been introducing in this paper, we also require something called as fault taxonomy, which actually classifies the faults both temporally and spatially. And then we'll be talking about the actual hierarchical framework and finally the recovery mechanisms. So why is fault tolerance important in distributed deep learning? As most of you know, the distributed deep learning, the deep learning happens across multiple nodes, across a very big cluster, and it could either happen by sending the data across to all these nodes and collecting the parameters at a central server, or we can actually run the model at different places and collect the parameters too. So at this scale, there could be a lot of chances for faults to be occurring, and that's where the appropriate and very efficient fault tolerance mechanisms are really important. The traditional fault recovery methods are fragmented, and they actually fail to address the interconnected nature of failures, leading to inefficiencies and potential cascade of failures. So before we move on to the actual framework, we should talk about what are the different kinds of fault classifications or the fault taxonomies. We have temporal faults and as well as spatial faults. The temporal faults are something that could be deterministic. They could be very periodic or stochastic or very random. And the spatial faults are the faults that can occur at a localized level, or they could be occurring at an intermediary level, or they could be happening at a cluster level too. If you're talking about a framework like Kubernetes, the faults could be happening at a pod level, at a container level, a pod level, or completely at a cluster level. Now, why this fault classification is important? Now, based on the kind of fault classification, we're going to use different kinds of recovery strategies. Now, this paper or this framework that we've been talking about is a hierarchical framework that tries to reduce the communication latencies, the communication inefficiencies that could happen in case of a fault that occurs in a distributed deep learning system. So the framework, we also employ specific synchronization protocols to ensure consistency across all the distributed components. I'm using the word component to refer to a container, a pod, or a node in a Kubernetes world, and while maintaining scalability. Now we can achieve a logarithmic level of communication efficiency when there's a fault tolerant, when a fault occurs in the system. So by integrating these recovery algorithms, these adaptive recovery algorithms and real-time monitoring, we can achieve significant efficiencies when a fault occurs in distributed system. So this is the actual hierarchical framework. In this specific approach, in this framework, there are different kinds of layers we're trying to classify as. So we'll be taking a layered approach to pod management and distributed learning. So we'll be starting from the bottommost layer of the container layer, then we move to the pod layer and the control plane layer, and finally to the cluster layer. So the framework could be mathematically expressed by using this specific formula. It's a very simple, straightforward formula. The LC for each of these ones over here represents a layer. So we have a container layer, a pod layer, a Kubernetes control plane layer, and finally a cluster layer. So let's dive into each one of these layers. So a container layer is where the actual work gets done. So this is where the actual training process happens, and we try to define the container layer in terms of 3 parameters: the actual training state, the training processing state, the memory that holds the model parameters and other configurations, and finally the environmental configurations. The next layer is the pod layer. It's more kind, you can think of it as more kind of a team leader that actually manages different kinds of workers, different kinds of containers, the container states, the network configuration between each of these containers, the volume mappings of each of these containers. The next layer is the higher level over the pod. This is the cluster layer, the cluster-wide layer, and this layer is responsible for managing all the pods in the cluster. It manages the resource allocation, the scheduling of the pods across different nodes, and finally, different kinds of policies that are enacted by your organizations or different kinds of authentication authorization policies. Now, pictorially, this is how we want to represent the fault tolerance. Anything that happens at the container level will be handled at the container level, and if it propagates, we'll try to handle at the pod level, and finally at the control plane layer and the cluster layer. We will try to minimize the communication efficiency, minimize the communication overhead between each of these layers so that the fault recovery could happen, the recovery from the faults could happen with minimum latency and maximum efficiency. So in general, we define a fault as in terms of this probability. The FA of t is nothing but the probability of fault occurring at time t for a layer I. And the same goes to the system state. And this probability can go between 0 to 1, where 0 represents an absolutely fine system and 1 represents a faulty system. Now, whenever a fault occurs, to recover from the fault, the nodes have to communicate, the components of the system have to communicate with each other so that they can do different kinds of recovery mechanisms. We'll talk more about the recovery mechanisms in the upcoming slides, but they can do different kinds of recovery. If they want to do different kinds of recovery mechanisms, there has to be some kind of communication that has to happen across all these components. And we are saying that the communication efficiency is at logarithmic scale. So this is the formula that we use to express the communication efficiency. The number 2 over there you see is because of the back and forth of the communication to happen. And again, we'll talk more about this recovery consistency, but we want to bring up one important point, that we don't want always to synchronize the state between the components when a fault occurs. We want to synchronize only when it exceeds a specific threshold t between the original state and the recovered state. Moving on. So what are different kinds of recovery mechanisms that we can have? So recovery mechanisms that we want to employ whenever a fault occurs is we want to maintain a state, we want to maintain some kind of state synchronization between the components. We want to have a progressive preservation, and the fault recovery has to happen with maximum resource efficiency. The state synchronization basically ensures that ensures consistency across nodes and different components using causal consistency protocols, which use vector clocks to make sure that updates happen in the right order. And we also use adaptive thresholds so that there is a minimum communication overhead, and we don't want to synchronize even for a small decrease thresholds or decrease from a given threshold. And we also want to periodically checkpoint so that whenever there is a fault that occurs, we want to recover from that fault by using checkpoint. There could be multiple version checkpoints, and we want to combine them and use the incremental updates to optimize this entire storage. So we want each of the checkpoints when deferred with other checkpoint, we want to do a diff between them and just store those incremental updates. Finally, we want to tailor this recovery strategies based on the fault classifications or fault types, also we discussed earlier, and also the severity level, for example, at a container level or a cluster level. Finally, finally, the recovery strategies that we're talking about, I already spoke about. We don't want to do a full state synchronization every time. We want to do it only when there's a major failure, and we want to do the incremental updates only when it diverges to be given threshold. And again, as we spoke about, we want to do it with minimal efficiency, maximum efficiency and minimal latency, so that we make the effective use of resources. A very good real-world integration that we are trying out at this point is by using Kubernetes. We have written our own custom resources and custom operators, which allows us to do it. As we said earlier, this is very, very scalable. As the number of components, nodes, pod, the containers increase, it increases at a logarithmic scale. The communication between these components increases at a logarithmic scale. And we're also planning to use some kind of dynamic resource allocation based on different kinds of parameters. So that we make the efficient use of all these resources. So our key contributions here are the unified fault tolerance, the hierarchical management, and the efficient recovery mechanisms, adaptive recovery strategies, and others. Finally, our future directions here are we want to work more on this by using the native GPU, TPU features. We want to enhance the security by encrypting these checkpoints and authenticating these protocols. And finally, we want to use predictive failure detection so that we can proactively identify these faults and proactively fix them. I think that's it from my side. You can always reach out to our email IDs. These are our email IDs. And thank you for listening to me. And I hope you guys have a great rest of your day. Thank you so much.
Okay, thank you, Mr. Prasan Josula, for your insightful presentation. We will now open the floor for question. If you have a question, please use the raise hand feature in Zoom. Kindly state your name and affiliation before asking your question. Okay, any question? Okay, Mr. Prasan, in your opinion, what is the biggest impact of this topic on society today?
Okay. Okay, so I work at a company called as Salesforce in San Francisco. So we do develop a lot of software. So I work in Salesforce AI Cloud. So we do healthcare systems today. At this point, we are developing a lot of AI things. So for example, when we go to a doctor, the doctor could use Salesforce software to recommend a lot of things to his patients. At this point, see, a lot of this patient data is really, really important, especially in countries like US. You cannot really share the patient information to anyone, especially to the central servers. So a lot of recommendations that we give to these doctors or the nurses who use the system are very much local. It should happen within the data centers or a central server they have. We cannot really propagate this data out. So since this data cannot be propagated out, a lot of information is missed out, right? So what we are trying to do is we are trying to do a lot of federated learning within this individual hospitals, individual data centers without pushing the data out to a central server. And at the same time, when we do this, what happens basically is there's a lot of faults that could occur. Really, the parameters that get aggregated, the central servers are not really accurate. And what we hope at this point by using this framework, that what we are suggesting is a lot of this error handling could be handled by using the central Kubernetes custom operator that we're going to come up with. In fact, we have been working on it for a long time. I cannot share the code right away, but we'll be soon sharing it.
Okay.
A lot of folks, and we're going to open source that code. So hope this helps a lot of people, a lot of nurses, hospitals, and all when we do this, when we complete this. That's it, yeah.
Okay, I think that's enough and very enough. Okay. Thank you for Mr. Prashant Josula. Okay, any other question? Okay, let us now present to our last presenter. Okay, please welcome Mrs. Raditya Maulida Putri. A warm round of applause for Mrs. Raditya Maulida Putri. Okay, for time reminders, you can also see them in your Zoom in the respective magazine in the right corner. Okay, thank you.
Is it my screen visible now?
Yes.
Good morning, everyone. It's an honor to have the opportunity to present my research today. The title is The Effect of Awareness, Trust, Privacy, and Security on Students' Adoption of Digital Banking. I hope that this presentation provides valuable insights and sparks meaningful discussions. The study looks at how awareness, trust, privacy, and security affect students' decision to use digital banking. Surveys were given to university students across Indonesia using a quantitative approach. Data was analyzed with an updated versions of the Technology Acceptance Model, or TAM, adding factors like awareness, trust, privacy, and security for a more detailed analysis. Previous research saw that 51.3% of students are highly aware of digital banking, while 4.7% have a very low awareness and trust. The study builds on those findings by introducing new factors and considering Indonesia's unique culture and education system. The results support all the proposed ideas, giving useful insight into what influenced students to adopt digital banking. These findings are not just helpful for academic research, but also offer practical tips for improving digital banking strategies in Indonesia. E-banking helps users manage finance, build trust with banks, and adopt digital services. However, low trust or awareness can discourage students from using it. Raising awareness, trust, privacy, and security is key in encouraging adoptions. Previous studies found 51.3% of students have high awareness, but 4.7% lack both awareness and trust. The study explored these factors and adds new variables to better understand what drives students to adopt digital banking. Ananda defines digital banking as the transformation of traditional banking into digital formats, allowing users to access services online without needing to visit physical branches. According to Ananda, digital banking adoption is users' acceptance of online banking. Awareness, trust, privacy, and security play a big role, especially for students. And technology acceptance model explain how external factors influence belief to predict the use of technology. In Poland's banking sectors, TAM successfully predict the adoption of contactless cards. Behavioral intention to use shows how likely someone is to use the technology. Based on two factors, perceived is obvious, the belief that the system is simple to use, and perceived usefulness, the belief that it improves performance. In this research, technology acceptance model with the addition of variables, namely awareness, trust, privacy, and security, to evaluate the use of digital banking application by studies. And there is 7 hypotheses in this research. Hypothesis 1 is awareness has a positive influence on perceived ease of use. Hypothesis 2, awareness positively affects to perceive of usefulness. Hypothesis 3, trust positively affects to perceive ease of use. Hypothesis 4, trust positively affects to perceive of usefulness. Hypothesis 5, privacy and security positively affects to perceive ease of use. Hypothesis 6, perceived ease of use positively affects to behavioral attention to use. And hypothesis 7, perceived of usefulness positively affects to behavioral attention to use. This research collects data directly from the source through observations, interview, and documentation. Using Fortune formula, 385 people were selected as respondents. The data was gathered using questionnaires given to students in Indonesia. The survey had 25 questions, and random sampling was used to make sure the results were fair and unbiased. According to Sugiono, a population is the group of objects or subjects used for conclusion. The study focused on 408 digital banking users, a similar or homogeneous group, exceeding the minimum 385 samples required by Cochrane formula for accurate results. Respondents are asked to rate on a scale of 1 to 5, where 1 corresponding to strongly disagree and 5 to strongly agree. This research used the partial least square method, a type of structural equation modeling, to analyze the relationship between variables. This research used Smart PLS4 software to test the validity and reliability data. It applies SAM with PLS estimation to check both the outer and inner model, ensuring the results are accurate and consistent. In the study, the validity test is used to check if the questionnaire measures the right variables and align with the study scores. And then in this research, reliability tests make sure the measurement results are consistent using Smart PLS4, Fortune Alpha, and composite reliability scores above 0.60 shows the data is stable and reliable. And this study checks the model using R-squared to see how well it explains the data. Squared to measure predictions, accuracy, and model fit to confirm everything works properly. And in the study, hypothesis testing is used to decide which of 2 ideas is correct. Since the sample size is more than 30, the z-test formula is used to analyze the result. The study included 408 students, 105 females, and 258 females. Almost all use mobile banking. Most had used it for a year, showing high adoption and experience among students. And the auto model analysis ensure the tools used are valid and reliable. Validity test checks if indicator measures the right variable are distinct from each other. Reliability tests like Fortune Alpha and composite reliability confirm the data is consistent. These tests ensure the tools are accurate and suitable for the study. In this research, all indicators have auto-loading above 0.70 and AVE over 0.50, proving they are valid. Discriminant validity is also confirmed with an HTMP ratio below 0.90, showing the model's construct are distinct and reliable. And then this research, the HTMP test shows all values are below 0.90, confirming good discriminant validity. This means that variables are distinct and measured accurately without overlap. And then the reliability test shows all variables meet the criteria with crossband alpha and composite reliability above 0.60
Sorry,
and
we have
heavy
2 minutes left.
over 0.50. This confirms the tools used are reliable and collect consistent accurate data. And then the hypothesis in this research, all variable relationship were positive and significant. Supporting each hypothesis 1 until hypothesis 7, awareness, perceived usefulness, and privacy and security significantly influence perceived ease of use, while perceived ease of use and perceived usefulness strongly affects behavioral intention to use. Trust also impact perceived ease of use and perceived usefulness, confirming the modus and reliability. And then the study uses modified PAM to analyze how awareness, trust, privacy, and security affect students' use of digital banking. Awareness improves understanding, trust, builds confidence, and privacy and security has safety. Ease of use and usefulness encourage adoption. The study is limited by its narrow focus and small sample area. Banks can boost adoption by educating students, improving security, and offering user-friendly system. So, thank you for your attention and interest in our presentation on the effect of awareness, trust, privacy, and security on students' adoptions. And if you have any question or feedback, I would happy to address them. Thank you once again, and we look forward to your thoughts and input. Thank you.
Okay, thank you, Mrs. Raditya Maulida Putri, for your presentation. Now we will open the floor for question. If you have a question, please use the raise hand feature in Zoom. Kindly state your name and affiliation before asking your question. Okay, any question?
Sorry, I wanna ask for Miss Raditya.
Yeah.
Okay. In your research, you highlight the significant role of awareness, trust, privacy, and security in student adoption of digital banking. Am I correct?
Yeah, that's correct.
So, how do you think socioeconomic factors such as income levels, access to technology, and financial literacy mediate this relationship? And what strategies can financial institutions adopt to ensure their services are inclusive and secure for all of the students? Thank you.
Okay. Thank you, Mr. Reza, for the question. That's a good question. So, socioeconomic factors plays a big role in how students use digital banking. For example, income level, access to technology, and financial literacy are important. Students from low-income families might not have easy access to smartphones, computers, or reliable internet. They might also not understand digital banking well, which can make them feel unsure or mistrustful of the services. Financial institutions can help by offering free or low-cost services to make digital banking more affordable. They can also provide simple, clear financial education programs that explain how digital banking works and how to manage money safely. By designing user-friendly platform, banks can ensure that even students who are not very tech-savvy can easily use their services. It is important for banks to balance security and convenience. They need to protect students' information while keeping the process simple and quick. When students feel safe and confident, they are more likely to use digital banking regularly. This approach helps build trust and makes digital banking accessible to students from all backgrounds. So that's the answer for me.
Okay, it's clear. Thank you for the answer.
Okay, any other question? Okay, thank you for Mrs. Aditya Maulida Putri for your presentation, and thank you to Mr. Reza for your questions. Okay, so ladies and gentlemen, this concludes the parallel session. On behalf of ICADEIS 2025, I would like to thank you to all presenters for their for your exceptional contribution and insight. So I will also like to extend my gratitude to all participants for your engagement and thought-provoking question. We hope this session has been both informative and inspiring. So, before we end this session, let our presenter to turn on your camera again, because we would like to capture a group photo for the last session. Please, Mr. Zain and Mr. Putu, to turn on your camera. Okay, everyone smile. Okay, 1, 2, 3. Okay, 1, 2, 3. Okay, thank you once again and have a wonderful day. Thank you. Okay.
Take care, all of you. Bye-bye.
Bye-bye.
Bye-bye, Mister.